Hello, it's 2025 and we're heading into the winter, and one of the things that's going to naturally come up in the drone industry is actually the use of drones with thermal mapping to understand heat loss and energy loss conditions for buildings. So what are the things that we need to keep in mind when it comes to using thermal data and drones? Let's have a look in this video. Hey everyone, I'm Varun from Hammer Missions, and in this particular video, what I want to do is I want to go into the top 5 things that you might need to consider if you're looking to do drone-based thermal mapping this winter. Let's have a look. So, number 1 when it comes to capturing drone data and thermal drone data is actually essentially capturing the data at the right time of the day. So, when it comes to thermal data, what we're really trying to do is we're trying to essentially understand what is the innate temperature of a particular structure, whether it's a building or something else, and the innate temperature must not be influenced by other things and other factors in the environment. One of the big things that can influence this innate temperature is actually the sun. So what you want to do is when you're trying to capture thermal data is to capture at the right time of the day, and this is typically either early in the morning before the sun's up, or late in the evening after the sun's down, so that you can reduce any interference from the sun on the building and you're able to actually capture the innate temperature for thermal mapping. This also applies to wind, by the way. So when it comes to essentially detecting cold spots and cold patches, winding conditions can actually lead to certain areas getting colder than others, and it can again influence how thermal data is collected. So capturing in low wind conditions and essentially stable weather with no precipitation is actually the best condition for thermal mapping. So no sun, no wind, no rain essentially is the motto. Just capture data where you can minimize any outside influence and actually capture the asset or the structure or the building in its innate form as much as possible. So number 2 is to actually use the right drone for the job. And by drone, I really mean the right equipment, which means the larger ecosystem of the thermal tuning of the data, so the software and all of the surrounding kit. So having the right equipment, so having drones that are correctly capturing radiometric JPEG images for your data that can actually be used for the thermal mapping is really important. And then also thinking through the entire process end to end, as opposed to just looking at the drone, is also really important. So you would want to make sure that your drone's capturing the data in radiometric formats. And then you also want to make sure that you can actually use that data in the right software to be able to analyze the building thermally. And one of the things we know from thermal data is that sometimes based on the drone you're using, you may not be able to directly use the images. You might need to process them. So we need to make sure that actually the drones and the software are all working together. For example, us at Hammer Missions, we've integrated Hammer to work really well with DJI Mavic 3 Enterprise Thermal and the DJI Mavic 4 Thermal. So if you're using any of those 2 drones, the data would automatically come out in radiometric JPEG and can be uploaded to Hammer Missions and scaled, tuned, and used for the analysis. It doesn't really matter what you're using in terms of the drones and the software. You're free to choose what you would like, but just make sure you've got complete compatibility with your drone, the software, and the analysis. So that's tip number 2. Tip number 3 is to essentially think about scaling and tuning workflows in thermal data. So thermal data essentially when it's captured may not be captured in the best way possible. So what I mean by that is the environmental conditions and the tuning you have of the temperature on the day may not be the most optimal tuning of the temperature in terms of being able to demonstrate those thermal anomalies. So essentially when you're going through the data, you might come across all sorts of issues. You might have an energy opening, energy loss issue that you've detected, and it may not be coming out as prominently in the data as you would like. And to be able to get that out in the right formats, what you really need to do is you need to constrain the range of temperatures in your data sets and to allow for that extra bright spots or extra cold or dark spots to really sort of come out in the data set. And therefore, having a piece of software, a piece of workflow where you can actually scale and tune all those temperatures is really important. Tip number 3 is to essentially look at capturing contrasting features with high overlap. So thermal data can be a bit difficult to stitch together, especially if you're trying to put together 2D maps and 3D models. And one of the things you have to bear in mind is that when it comes to stitching together thermal data, a lot of it is based on photogrammetry, and photogrammetry really requires features in the scene to essentially have different contrast. It's a bit like if you were mapping a featureless surface, something like a metal roof or some form of a geometric pattern or water where you don't really have contrasting features. And so you just want to be mindful that when you're capturing the data, you're capturing it in the right spectrum. So for example, the iron bow spectrum can typically be really good for thermal mapping. And once you've got the right spectrum, you want to make sure that you're seeing contrasting features in the scene to be able to actually put all that data together. If you're not seeing contrasting features in your images, one thing you could try and do is to try and sort of raise the altitude and you get more features per image in your scene. And you can also try and play with how much GSD you can essentially afford to lose with respect to the altitude. So striking a good balance there and having contrasting features in your data set is really important. And getting a high overlap on top of that is also equally important, just because of the fact that it's thermal data and it really requires all the support you can give it when it comes to stitching. But doesn't mean it's impossible to stitch thermal data. We've seen many data sets that have been processed using thermal data, and all you have to do is just bear in mind those good practices and you'll have a good data set that can be analyzed, because it can be a pain to go through all the images one by one. So really what you want is a stitched 2D map or a 3D model, and then have that analyzed by a qualified thermographer when it comes to thermal mapping. And then the last final sort of tip I would leave you with is essentially to think about capturing the data as much as possible being perpendicular or orthogonal to the surface. So if you're capturing a roof, try and stay at the same altitude, the same GSD to the roof. Do not use any oblique imagery. And also when it comes to mapping a facade, try to capture it as much as possible by staying perpendicular to the facade. And the reason for that is that oblique images can sometimes lead to distortion in temperatures, and they don't necessarily give you the level of accuracy you need to perform a very accurate and confident survey with respect to thermal data. So if you're capturing the roof, stay perpendicular to the roof. If you're capturing the facade, stay perpendicular to the, and essentially that way you're able to get high quality data in a safe and compliant manner. So that's it, guys. This is a very quick video going through 5 of the main things that you would want to keep top of your mind when you're trying to capture, process, and analyze thermal drone data. If you're curious on what a thermal drone workflow looks like, you should watch this video next. Thanks so much for watching. We'll see you in the next video at Hammer Missions.